Alright, in this video we want to find the reactionary forces at point A and point B. So we want to find out the forces that are caused due to this 50 newtons. So the reactionary forces due to this 50 newtons at point A and point B. Now point B does not prevent any forces in the x direction. It only provides a normal force from whatever it's sitting on. That's what rockers do. So it only provides a by force, a force in the y direction. So it only prevents forces that come straight down on it. And again, it does not provide any forces that come this way or that way. It also does not prevent rotation at this point. It does not prevent any rotation at this point. Now A is the same thing, kind of, that it doesn't prevent any rotation at this point, but it does prevent forces that push it up or push it down, in addition to pushing it this way or that way. So it's a hinge, and hinges allow it to rotate, but just not move from this point. So we want to find out what forces are due to, or what are the reactionary forces at A and B. And notice B can only provide forces straight up. So it can't hold it down. It cannot hold it down like that. It will be lifted up that way. So I just kind of wanted to point that out. So let's get started. Alright, so we have this truss, and each one of these is 4 meters long. So that means the inside of these angles, that these are all the same lengths. So that means each of these angles are the same because we have an equilateral triangle. So if this is 60 degrees, this is 60 degrees, that means that this total angle right here is 120 degrees. So 120 degrees. Now if we put in a 90-degree angle right here, so then we just minus 90 degrees, and we could actually get this angle. That is equal to 30 degrees. 30 degrees. So I'm going to erase some of this. So now we have our force, or not, the angle of our force. So that's 30 degrees. So now we just need to find the y component of the force and the x component of the force. The x component, Fx. So if we remember SOHCAHTOA, whoops, TOA. We have the hypotenuse, and we want the opposite. So the Fx is the opposite, so Fx is equal to the force times the sine of the angle, and that is equal to, pull out a calculator, that is equal to 30 degrees, or the sine of 30 degrees, times 50, which should just be 25. So that is equal to 25 kilonewtons. And now we're going to find the y component. So we want this side, the adjacent. So that would be the force times the cosine of the angle, which is equal to, again, 30 degrees for the angle, so 30, but we want the cosine, times the force, which is 50 newtons, equal to 43.3 kilonewtons. 0.3 kilonewtons, and I always like to check myself. So if a squared plus b squared will equal c squared, so just test that real quick. So we'll square this, plus 25 squared equals, I did something wrong. So we have 43.3 squared plus 25 squared equals, there we go. So 49.99 newtons, so we were right. So now we know what Fx and Fy are. I'm just going to write that up here. Fx is equal to 25 kilonewtons, sorry. 25 kilonewtons. Fy is equal to 43.3 kilonewtons. Now I'm just going to erase all this. Now, if this is static, then the summation of the forces must equal 0. So the summation of the forces in the x direction must also equal 0, or that basically saying the summations in the x directions and the summations in the y direction must both equal 0. So what are our forces in the x direction and what are our reactionary forces? B, this is B. B does not prevent any x forces. It does not provide any forces in the x direction. So it's 0. So Bx is equal to 0. What about A? Well, A does provide something, but we don't know what it is. So Ax does provide some force either that way or that way. So Fx is this way, Fx, and it was equal to 25 kilonewtons. Kilonewtons. So then the summation of the forces in the x direction is equal to Bx plus Ax plus Fx. This is 0. So if we move this Fx over here, we get Ax is equal to a negative Fx. And that is equal to a negative 25 kilonewtons. So we found what Ax is. So Ax is equal to a negative 25 kilonewtons. Now let's do the same thing for the y components. But B, this time B does provide a By. We don't know what it is, so this must equal By plus Fy, and A also provides some force on the y-axis, so plus Ay. So we couldn't do what we did in the last one. We have to actually go to our next part, which is the summation of the moments. The summation of the moments, which is equal to 0. And I'll actually continue this on in the next video.